Hi guys and welcome back. Today I just wanted to make a really quick video going over some of the things that I want to cover on this channel in the future, and also to apologise for it taking me so long to release anything since the fog video came out. I know a lot of people have been wanting a tutorial on that, so that is going to be one of the first videos that I do. I do plan on covering the volumetric stuff in a separate tutorial series later on, but of course we will be covering some of that when it comes to the fog tutorial as well. If you watch that video, you'll know that I've been working on a sky and weather system, and that's what's been taking up a majority of my time. So that's why it's taken me so long to actually release anything. So I apologise for that, but let's get into some of the things that I want to cover. As you can tell from these categories, and as you probably already know if you've seen the other video, this will be a tech art focused channel. So we'll be focusing on blueprints, shaders and Niagara, and building some systems and tools that we'll be using to make our quality of life a bit better and to increase productivity and do some really cool, fun things further down the line. To begin with, we'll be looking at blueprints. This will be blueprint communications, so that's interfaces, event dispatchers, when to use them, when you shouldn't use them, and the best use cases for these. Then there'll be a similar video about avoiding tick, using timers, functions, that kind of thing. This is a very important topic. You see a lot of people say you shouldn't use tick, or you see people overusing it, but we'll go over that and we'll cover when and when you shouldn't use it. Then we'll go on to a video about class hierarchy. This will be something you'd be very, very familiar with if you come from a coding background, but if you're coming straight into blueprints or into Unreal, this might not be something that you have wrapped your head around to begin with, but it's very important, and we'll cover why it's important and how to set up good class hierarchies and get a good understanding of that kind of thing. We'll then move on to blueprint organization. So this is once we've created a tool and we have all of our variables and everything in there, how we're going to organize that, how we're going to make it user-friendly for someone else down the line. We'll then move on to our shader series, which will be split up into three categories: fundamental, intermediate, and advanced. We'll cover what is a shader to begin with. This might be a silly question, but a lot of people know what a material is, but they don't actually understand what a shader is doing under the hood and how it works. So that's what we're going to cover there. We'll then go over shader domains. So you may have heard of the vertex domain, pixel domain. All of those sort of things will be covered, and how we can leverage those to increase performance and that sort of thing. We'll then move on to covering textures and coordinates. A texture is obviously an image, but it's a lot more than that. It's actually a 2D array of data that we can manipulate in lots of different ways, and obviously using the coordinates to read those in different ways to create some really interesting results and create some cool things. We'll then talk about channel packing, and we'll use this tutorial to also create a blueprint channel packer that will pack our textures together for us in whatever way that we want, and then we'll be able to save those out afterwards. So that's a very useful one. It's a nice little tool that we'll be building there. I then want to cover some basic shader math. So this is the vector math, how to use it, sort of the things that you should know that may seem sort of hard to wrap your head around to begin with, but they're actually quite simple. So we'll go over some of that math stuff there. We'll then also talk about reducing instruction counts, how we can optimize our materials, and what functions are more expensive than others, and how we can reduce some of those counts and leverage a bit more performance from there. And then in our intermediate section, we'll move on to talking about render targets, how we can write to these in various different ways, how we can read these, and how we can leverage them. We'll then talk about scatter and gather methods. This is something you may have heard before, but if not, don't worry, because it's going to be covered here. We now have both of these methods available to us in Unreal, and we can use these to do some really interesting stuff with shaders, so that's going to be quite a fun one to cover. I also want to do a video about distance fields, understanding them properly, how we can use these and leverage these and use them to do things like creating custom collision functions inside Niagara, for example. I then want to cover shading rate, which is something that's actually very new to Unreal. It's quite a new technology with DirectX 12. I won't cover it too much here, but that should be an interesting video. It's just a way that we can, again, improve performance at purely a material level, but we'll cover all of that in the actual video. Then virtual texturing obviously is quite a big one. This may be a sort of a sub-series in itself. I want to cover that, how to use it with landscapes, and how we can then use that with objects to create nice object blends, using what we've learned about distance fields as well, leveraging both of those to create some nice seamless transitions between geometry and landscapes, for example. We'll then start to cover volume textures, which may seem like something that should be in the fundamentals, but it leads on nicely into more of the advanced stuff when we start talking more about volumetrics and fluids and that kind of thing. And in that vein, I want to talk about advection, curl and divergence. This is something that is very important when it comes to fluids and volumes. Don't worry, again, if you don't understand that now, that's something that I'll be covering in great detail on how we can do this correctly and the common mistakes that I see people doing when they're using advection or panning textures using some kind of velocity mask. Then in our more advanced section, we're going to talk about understanding volumetrics a bit more, sort of what they are in terms of a game renderer and how we can work with these. So when you think of a volume, in terms of a game engine, this isn't actually a volume. It's a volume represented by a surface using a parallax effect, if you will, which is what ray marching is. I'm sure you've heard of ray marching before, but we're going to cover that in its own video, understand it a bit better, and then we'll move on to starting with HLSL, which opens a lot of doors in terms of shaders and things down the line. Luckily, it's a very simple language to get into, so we'll cover that in a few videos, and we'll actually build a ray marcher, so you'll get a good understanding of how that works, and hopefully a pretty good understanding of the basics of HLSL, so that you can move forward and learn some more on your own. And I'll also be, of course, releasing some more videos in the future as well on that. We'll then move on to talking about Niagara. We'll start with the basics and the workflow, or my workflow at least. This is the workflow that I've found works best for me and seems to be very quick and it's iterative. So we'll cover that there. We'll then go into understanding variables and namespaces a bit better. This is something that can be a little confusing when you first start with Niagara. The system as a whole can actually be a little confusing to begin with, but we'll be covering it from the basics and moving up from there, so you should get a really good understanding of that and how we can leverage namespaces and what they actually mean. We'll then go on to cover data interfaces, so that will be 2D grids, 3D grids, render targets, all that sort of stuff. We won't go over all of them in one video, of course, so that might also be a sub-series in itself. But we'll cover all the data interface types, hopefully, and how we can use these. We'll then move on to creating custom modules and functions, as well as some of the neat tips and tricks that we can use to create some nice modules and functions that are we can plug into all kinds of emitters, and we can set prerequisites and all that kind of thing. So we'll look at setting those up there. We'll then move on to blueprint communication. So that's from Niagara to blueprint and from blueprint to Niagara. This opens, again, a lot of doors. Niagara at this point is a very powerful system that's capable of a lot more than just particles, which we'll cover here when we start talking about simulation stages as well. This is something that's extremely powerful, allows us to iterate over various stages in a shader and do things that would require us before to ping pong render targets or that kind of thing. These can now all be done in a single frame, which is very powerful, which then, as we move on to using Niagara as a compute resource, we'll be leveraging this a lot and using this to write to 2D and volume render targets, which are now in UE4, but the only way to currently write to them is using Niagara. So we'll cover all that kind of thing, and then we'll move on to sharing data between emitters using the particle attribute reader. So that should be a good series, because Niagara at this point is it's extremely powerful. So we can use it to do more than just render particles at this point. These last three categories are then from scratch. This is where we're going to be building tools and systems using what we've learned from these other tutorials. So as I said, the fog will come early on, but then we'll also be looking at spline-based CPU and GPU particles. On CPU, this is simple, but on GPU, it requires some knowledge of render targets and some other fun stuff. So that's one to look forward to. We then will move on to an ocean shader. This is something I've built in the past, but uses a lot of what we're going to be learning about shaders, because it's quite complex at the end of the day. So we're going to be using quite a lot of math when it comes to generating waves. We'll also then look at the post-process for like the waterline effect, the underwater fog, and looking at how we can render the surface from the underside and the top side with effectively different materials. Volumetric clouds is a huge topic, as I found with the sky and weather system. There's a lot of stuff you can do with it. So this will probably be a mini series in itself, but we'll cover creating basic clouds and then how we can create some more complex systems and how we can use this to blend between fog and clouds, so we can have distant fog using the cloud system rendered in the distance, and then blend that with volumetric fog up close, so we can get a seamless transition between the two and still get you can get that noisy, distant fog effect that you can't currently get when you're just writing to the volumetric fog that is up to, well, around 6,000 units, I think, something like that. So that should be fun as well. Then there is the real-time Cortex example. This is something that I just played around with recently, but leverages the scatter and gather that I was talking about. That uses a lot of some of the fun math and simulation stages inside Niagara and that kind of thing. So again, that's going to be another fun one to do. Then the last two topics here, one is general development. This is just sort of more general stuff, so not tech art focused. This is things like managing expectations. So especially as a solo developer, it's very easy to get carried away with big ideas, but at the end of the day, you are still only one person, and it's important to sort of understand your limits and how to work within those limits and how not to get yourself bogged down basically in your own project. And a lot of these are going to be sort of in a similar vein, like focusing on the bigger picture. Again, is just about not getting bogged down in the details and how to sort of block out and build your game out so you have your base first, and you're not focusing straight in on the details. The importance of reference sort of speaks for itself. We'll be talking about reference and some useful programs to collect and look at reference. Planning, again, similar thing. We'll be looking at why it's important to plan, especially when we start talking about things like class hierarchies. It's very important to plan that early on so that it doesn't come back to bite you later on, basically. And then we'll be looking at why iteration is important as well. So these are going to be quite similar, but more general sort of topics. And then Q&A is the last one. So this is if you guys want a specific tutorial or if you have any questions about anything, then please put them in the comments, and I will probably collate these questions over time and then try to answer them the best that I can, either in a video or maybe I'll reply in the comments. I'm not sure yet, but if you guys have any questions, then please ask and I'll do my best to answer them. So Fog tutorial will be coming out very soon, I promise. Thank you guys for watching. Like and subscribe, and I'll see you very soon.